Welcome to STEM Education with Olufemi. I'm excited to have you here on our channel where we make STEM topics accessible and fun for everyone. Our mission is simple: to break down complex mathematical concepts into easy to understand lessons that anyone can follow along with. Today, we're diving into one of the most fundamental concepts in mathematics: linear equations. These equations form the foundation for so much of algebra and beyond. If you're new here, make sure to hit that subscribe button and ring the notification bell so you never miss our latest STEM education videos. Now let's get started with linear equations. A linear equation is a fundamental concept in algebra. Let's explore what makes an equation linear and how to identify one. A linear equation is defined as an equation where the highest power of any variable is 1. This means variables appear only to the first power, never squared, cubed, or under square roots. The key characteristic is that all variables must have a power of exactly 1. No variable can be squared, cubed, or have any other exponent. Now let's look at some examples to understand this better. We'll compare linear equations with nonlinear equations. Here are examples of linear equations. Notice that in each equation, every variable has a power of 1. The variables x and y appear only to the first power. In contrast, these are nonlinear equations. The first has x squared, the second has x under a square root, the third has variables multiplied together, and the fourth has x cubed. See how the nonlinear equations have variables with powers greater than 1, or variables under roots, or variables multiplied together. These features make them nonlinear. An important property of linear equations is that they represent straight lines when graphed on a coordinate plane. When we graph a linear equation like y equals 2x plus 3, we get a perfectly straight line. This is why they're called linear equations. They create linear or straight line graphs. To summarize, linear equations have variables with power of 1 only, they graph as straight lines, and they don't have variables multiplied together. These are the key features that define a linear equation. Now that we understand what makes an equation linear, we're ready to explore the different forms that linear equations can take. Now we'll explore one of the most important forms of linear equations, the slope-intercept form. This form makes it easy to identify key characteristics of a line just by looking at the equation. The slope-intercept form is written as y equals mx plus b. In this form, m represents the slope of the line and b represents the y-intercept. Let's create a coordinate plane to see how these components work visually. Here's our coordinate plane with x and y axes. Now let's plot a line using the slope-intercept form. Let's use the example y equals 2x plus 1. Here the slope m equals 2 and the y-intercept b equals 1. The y-intercept is where the line crosses the y-axis. Since b equals 1, our line crosses the y-axis at the point 0, 1. Now let's draw the complete line. The slope of 2 means that for every 1 unit we move right, we move up 2 units. The slope represents rise over run. With a slope of 2, we rise 2 units for every 1 unit we run to the right. Now let's see what happens when we change the slope value. When the slope is smaller, like 1/2, the line is less steep or more gentle. When the slope is larger, like 4, the line becomes much steeper. Now let's see how changing the y-intercept affects the line. When we change b to 3, the line shifts up. It now crosses the y-axis at 0, 3, but the slope stays the same. When b is -2, the line shifts down and crosses the y-axis at 0, -2. The slope remains 2, so the steepness doesn't change. Remember, in the slope-intercept form, y equals mx plus b, m controls how steep the line is, while b controls where the line crosses the y-axis. This form makes it easy to quickly understand and graph linear equations. Now let's explore the standard form of linear equations, which is another important way to represent linear relationships. The standard form of a linear equation is written as ax plus by equals c, where a, b, and c are constants. In this form, a, b, and c are constants or fixed numbers. A and b cannot both be 0 at the same time, and by convention we usually write a as a positive number. Let's see how to convert between slope-intercept form and standard form with some examples. First, let's convert from slope-intercept form to standard form, starting with y equals 2x plus 3. Step 1. Move the x term to the left side by subtracting 2x from both sides. This gives us y minus 2x equals 3. Step 2. Rearrange the terms to match standard form ax plus by equals c. we get negative 2x plus y equals 3. To follow convention and make a positive, we multiply everything by negative 1, giving us 2x minus y equals negative 3. Now let's try the reverse conversion from standard form back to slope-intercept form. Starting with the standard form equation, 3x plus 2y equals 6, let's convert this to slope-intercept form. Step 1, isolate the y term by subtracting 3x from both sides. This gives us 2y equals negative 3x plus 6. Step 2, divide everything by 2 to solve for y. This gives us y equals negative 3 halves x plus 3, which is now in slope-intercept form. Now let's discuss why standard form is useful and when we prefer to use it. Standard form is particularly useful for three main reasons. First, it makes finding x and y intercepts very easy. Second, standard form is extremely helpful when solving systems of equations using elimination method. Third, standard form clearly displays integer coefficients, making calculations cleaner in many situations. For example, with 2x plus 3y equals 12, we can quickly find intercepts. For the x-intercept, set y equal to 0 and solve. For the y-intercept, set x equal to 0 and solve. Standard form A, x plus by equals c, is a powerful way to represent linear equations, especially when working with intercepts and systems of equations. Now we'll learn how to solve linear equations with one variable. The key is to isolate the variable by performing the same operations on both sides of the equation. Let's start with this equation. 2x plus 5 equals 11. Our goal is to find the value of x. Think of an equation like a balance scale. Both sides must be equal. Whatever we do to one side, we must do to the other side to maintain balance. Now let's solve this step by step. First, we need to isolate the term with x. Step 1. To eliminate the plus 5 on the left side, we subtract 5 from both sides of the equation. This simplifies to 2x equals 6. Step 2. To isolate x, we divide both sides by 2. This gives us x equals 3. That's our solution. Let's verify our answer by substituting x equals 3 back into the original equation. Perfect. When we substitute 3 for x, we get 11 equals 11, which confirms our solution is correct. Let's try another example. 3x minus 7 equals 14. First, we add 7 to both sides to get 3x equals 21. Then we divide both sides by 3 to get x equals 7. Remember, the key to solving linear equations is to perform inverse operations to isolate the variable, always doing the same thing to both sides to maintain the equation's balance. When we have a linear equation with two variables, like x plus y equals 5, something interesting happens. Unlike equations with one variable that have a single solution, this equation has infinitely many solutions. To understand why, let's see what happens when we choose different values for x and solve for y. Let's start by choosing x equals 0. Substituting this into our equation, we get 0 plus y equals 5, which means y equals 5. So one solution is the point 0, 5. Now let's try x equals 1. Substituting gives us 1 plus y equals 5, so y equals 4. This gives us another solution, the point 1, 4. We can continue this process with any value of x. Let's see a few more examples. Here are several more solutions. Notice that for any value we choose for x, we can always find a corresponding value for y that satisfies the equation. The key insight is that there are infinitely many solutions because we can choose any real number for x, and there will always be a corresponding value for y. Now here's the most important part. All these solution points lie on a straight line when graphed on a coordinate plane. Each solution we found represents a coordinate pair, and when we plot these points on a graph, they all lie on the same straight line. This line is the graph of the equation x plus y equals 5. This is why we say that a linear equation with two variables represents a line, and every point on that line is a solution to the equation. Now we'll learn how to graph linear equations. There are two main methods we can use to create accurate graphs of linear equations. Method 1 uses the slope-intercept form. Let's graph the equation y equals 2x plus 3. In this form, m is the slope, which equals 2, and b is the y-intercept, which equals 3. Step 1. Start by plotting the y-intercept. Since b equals 3, we plot the point at coordinates 0, 3 on the y-axis. Step 2. Use the slope to find another point. Since the slope is 2, this means rise over run equals 2 over 1. From our y-intercept, we move up 2 units and right 1 unit. From the point 0, 3, We move right 1 unit and up 2 units to reach the point 1, 5. Step 3. Draw a straight line through both points. This line represents all solutions to the equation y equals 2x plus 3. Now let's look at the second method for graphing linear equations using intercepts. Method 2 uses x and y intercepts. Let's graph the equation 2x plus 3y equals 6 using this approach. To find the y-intercept, we set x equal to 0. Substituting gives us 3y equals 6, so y equals 2. The y-intercept is at point 0, 2. To find the x-intercept, we set y equal to 0. This gives us 2x equals 6, so x equals 3. The x-intercept is at point 3, 0. Finally, draw a straight line through both intercept points. This line represents all solutions to the equation 2x plus 3y equals 6. Both methods give us accurate graphs of linear equations. Choose the method that works best for the form of equation you're given. We've covered a lot of ground in our exploration of linear equations. Let's quickly review the key concepts we learned today. First, we learned what linear equations are: mathematical expressions that create straight lines when graphed. We explored the slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. We also learned about standard form, ax plus by equals c, which is useful for certain types of problems. We practiced solving linear equations with one variable and systems with two variables. Finally, we learned how to graph these equations to visualize their solutions. Thank you so much for watching this comprehensive guide to linear equations. If this video helped you understand linear equations better, please give it a thumbs up. Don't forget to subscribe to STEM Education with Olufemi for more amazing STEM content. Leave a comment below with any questions you have or suggestions for future videos. I love hearing from you. Keep practicing these concepts, and remember, mathematics is all around us. See you in the next video.